Morning.
John, hello. Nice to see you. Nice to meet you.
Oh, you're on mute. Oh, wait, maybe my volume just turned down.
Okay.
There we go.
Hey, nice to see you.
Good to see you.
Yeah, I'm pleased to meet you. Thank you for jumping on. I, I've been talking to Marlo, and she had been, yeah, yeah, John is good, John is good, and all of a sudden I realized that I hadn't seen that from you, and so I decided to check.
Yeah. I somehow I never got an invitation or something, so I had, yeah.
Yeah, it's great I asked, and thank you so much. I watched some of your videos about DRA stuff. I believe that we will indeed have a lively conversation today. So,
Okay, good.
yeah.
Well, yeah, okay, good. Probably be nothing new from what you if you watch some videos, but that's okay.
I
I mean,
I
before we
held
did
off
stuff.
watching the one from 3 weeks ago. I watched the one from like 24 and last year North American KubeCon stuff. So, um, but I bet there will be people here who are not so caught up. So
Sure. Yeah,
it'd be
yeah.
interesting to see where we decide to start. Hey, Philip, nice to see you.
Alex, hey guys, nice to see you.
Yes. Who we got on? Alex, nice to see you. Victor, lovely to see you. Thanks, Victor, for having me at the OCP talk the other day. I hope it was useful. I, as always, thought I'd talk for 10 minutes and then talk for 40. I'm sorry. I'm sorry.
That was good. Yeah, actually, invited John as well to present in April.
Oh, say again? Something in April? What?
You invited John to present in April.
Oh, your job to present. Yes, good luck. What are you going to talk about?
No, he's saying he invited me to present in April. I'll be presenting there.
Oh, shit. Sorry, I thought that was still Victor talking. I wasn't watching.
No, it was
Sorry.
Victor. He said John. It just yeah.
I didn't hear it.
Okay.
Yay. uh, waking up still. Waking up.
So there are a lot of interesting, like the data locality thing I mentioned. Uh, there's a John, Alex. There's sub work stream in this meeting about data locality. And last year, one of the sub work stream in OCP was data locality.
So there's some overlap here, huh?
Yeah, I loved where that meeting ended up with like, we will have perfectly flexible hardware that can respond to any sort of workload, and we just need to work it through every single layer of the system. Let's go. It's like, oh, sweet. Yeah, it's going to be easy. Um,
That's where I feel the different layers need to talk and see what's the problem and resolution solution proposed for each layer.
yeah, agreed. Um, yeah, we should do more talking. I didn't quite have a concrete idea of how we should all like. Should we meet? Should we talk? Should we white paper? Should we like? I couldn't quite figure out what to propose, but maybe you and I can take that offline and figure some stuff out. Love to see some folks. Alan, Marlo, hello, nice to see you. Du-du-dum. Wait a couple more minutes to get really going. It was great. I jumped onto the to this OCP thing that Victor invited me to, and at some point brought up the white paper, Marlo. I realized that Sabrina had totally already done all the work to split them up into 5 different
No,
papers.
she's done a great job.
Yeah, it's
Yeah,
fantastic.
we're still
Yeah,
waiting on a review from a talk member though, which is a thing.
we should start inviting them here so that we can shame and guilt them into looking at it.
have someone who's promised to work on it, but has not yet. So let me go reping.
If they've made a promise, you can definitely shame them. Yes.
Yeah, there will be
Good.
shaming.
Good. Yeah. Anyone headed to GTC next week? I mean, Marlo. Hi.
Hi, I'm not going.
Oh,
But
okay.
Tim is.
Nice.
No, because it's right on the head or tail, yeah, of KubeCon is right after. So
Yeah. Yeah. Yeah.
one at a time. Thanks.
Well, expecting a couple more people to jump on, particularly about this topic. Um, dun-dun-dun. Maybe let's just roll into quickly updating on the other sort of work streams that we have going before jumping into the DRA stuff with John. Marlo, wanted to give an update on we just sort of talked about it, the white paper stuff.
So it looks like we are good to go. So we're waiting on final review from the talk. Let me put the draft in here for anyone who's not already aware of that.
For you, John, this is a white paper that was actually started by another working group but never got over the line. And that working group has since disbanded, and we were asked to pick it up and get it over the line. We got it over the line, and it was like 40 pages long, and the talk came back and said, oh, there's a new rule, not allowed to have a white paper longer than 10 pages. So Sabrina wonderfully, dutifully went back to the drawing board and split apart the white paper into 5 separate pieces, and the result is over here.
She did a really great job of splitting because she also added in each one sections for series introduction, executive summary, and then previously, like we're doing episodes.
Yeah, she she did a similar thing. I worked with her on a quantum report that we did for ISC, and it was great. Like we just sort of like talked at her for a while, and then we came back like a week later, and she had this amazing 40 or 50 page thing. We're like, what? We sound amazing. We sound so smart. How did you do this? It was great. So, yeah, she's rad.
She's
So
worth her weight in gold. I hope you're compensating her well.
absolutely, that's right, Philip. Right? We totally, yes, totally.
Totally.
Yeah, no, don't worry. We know she's awesome. Anything else to say about the white paper at this point? Like, go check it out.
You can go check it out, or you can wait for it to get published. I don't know where stuff gets published at this point.
I mean, if you do read it and there is some like late breaking change, if you see something that is just flat out wrong, like let us know before it gets published. But we'd love to just get it over the line. So if there's not something violently wrong, we can always write it into the next white paper. So the other thing, Philip, do you want to? Do you have any updates on the benchmarking thing that James is running?
Yeah. Here's the document, just to refresh the memory. So right now we're working on phase 1 lines. There is another technical document which will be shared after we format it a little bit and style it out. So right now we are working on the creating a set of specific benchmarks and components which should be tested as bottlenecks in the cluster setup. So while working on that, we are also defining where code will be stored and where we can test things out online. So a few things in parallel. We are getting into the pace with this project.
Cool. Do either you or Marlo want to give some context for what this is? I don't think John, Alex, or Alan, maybe Alan, you know a bit about it, but just brief bit of context. What we're planning to benchmark potentially.
Um, the initial part of this, and maybe it's not batch specific, was to try to get something similar to LinPack so we can actually see performance on these large systems for AI type workloads. Because we don't currently have something that's not run a model. We should really be doing things that are smaller targets so that we can better figure out what on a particular system is broken and improve. And then the next step will be something around, try it with different schedulers and see what their locations are if they change the performance of particular workloads for on average.
Yeah. I think that's about it in terms of the updates. I don't think there's anything from my side on like housekeeping stuff. I think the transition to the new platform has happened as it was. So we're using the new Zoom stuff. Marlo, you're headed to KubeCon. I think a few people on my team are headed to KubeCon. We'll have a Armada kiosk there on the Tuesday afternoon, and we'll also have like just like a open house party thing. I can send links around to that stuff. Nice people, fun. If any of you going, Alan, are you going? No.
I'm not, I'm afraid. No. I said that I have to be in New York the week afterwards, and I think two on the trot was going to be a little bit much. Family.
Yeah. I know the KubeCon supercompute thing late in the year is always a bit of a doozy.
Plus KubeCon next to TSA shutting down. That seems to be a new thing now.
Oh, is that happening in Europe now? Wait, again?
Well, you have to get from the US to Europe, so this will be fun. And yes, again.
Yeah. Happy times. Alex, are you headed to KubeCon?
I'm not. I was just checking to see if my colleague from MERS is going to be there. He's been before, but I'll see if he's there, and I'll send him your way if he is.
Yeah,
if he is.
Please do. Yeah, I'll chuck the. Are you in the Slack? I'll chuck the my team being at the kiosk time thing in there.
I'm not in the Slack. I can't remember to what extent we can access external Slacks, but if you can send me the details, I'll try.
Right. I might be able to connect with you in there's an external connected Slack. Anyway, I'll get you.
If you know how to do it, let me know.
Yeah. Cool. John, are you headed to KubeCon?
Oh, yes. Mm-hmm.
Yeah, I imagine. Do you have a talk there? You've had talks.
I did not submit a main session talk. Marlo and I have there's Sunday's the Maintainer Summit. So Marlo and several others and us have a panel we're going to do. And then I do have a couple maintainer track talks. So I have a talk for workgroup device management and one for Core DNS, which I was involved in many. I mean, still involved in, but like that was my original entree into the Kubernetes world. So
nice. Well, cool. I think that's it for current events as it is in our little team here. DRA stuff. Let's switch to that. John, you want to introduce yourself and sort of your relation to DRA?
Sure. John Balameric. So I'm so DRA started before I got involved, but about 2 years ago, actually around KubeCon EU 2 years ago, DRA wanted to go to beta, and there was a lot of pushback from the community because of the design that was there. So I've been involved in Kubernetes since, 2015, 2016, something like that. And I'm co-chair of SIG architecture for many years now. I got involved with Patrick and Kevin, who had started this, or at least had been working on it for a couple of years. And we worked together to shift the design to be something more amenable to things like auto-scaling. And I think that from the point of view of this group, if I understand who's here, with external schedulers, it's probably also better for you. One of the issues with the original design was it was sort of like there was an opaque controller which kind of handled scheduling of each individual type of really arbitrary thing. Like we call them devices now, but it was just like there were a set of arbitrary callouts to third-party controllers that would make scheduling decisions. So like you couldn't look at the resources available in the cluster and look at the requirements of the workload and actually make any kind of decision about whether that workload would fit on that given node. This is still pod to node scheduling. And so because you had to, there were third-party things, an arbitrary number of them that had to kind of negotiate the set of nodes. And so if you think about auto-scaling, that was kind of impossible. So because the autoscaler couldn't decide if spinning up a new node would work. And so that was one of the sort of fundamental issues with it. So anyway, that's kind of a lot of history, but yeah. So I got involved, and Patrick and Kevin and I worked really closely with Tim Hawken, and we came up with a new plan, and we formed Workgroup Device Management to help kind of bring in more community input to that plan and make sure that we're on the right track. And I see some folks here. I think Abhishek and I have talked a lot about this in the past. Obviously Marlo, and so we, they were both involved since early on this effort. And yeah, so that's so now I'm one of the chairs of Workgroup Device Management as well as SIG architecture. And most of the last 2 years has been focused on DRA and trying to move it from where it was to it's now GA, but we also have like more than a dozen additional features like in the pipeline that are built on top of it.
And that, I think that when it was going GA, it was also KubeCon Amsterdam, if I remember. Was that the same thing? Was it
that? Let's see. I don't know. It was the one. It was Paris, I think, where I got involved.
Okay.
I don't, but I think the drama started in the NA one before that, maybe. But I wasn't really
got it.
Doing something else, and then it was it was clear there was a strong need for it, right? With the AI workloads becoming more relevant. Then it was like, well, we need to understand GPUs better. We need to understand accelerators better. But we don't think this is quite the right design. And we kept a bunch of pieces of the design. I mean, the whole kubelet side of it stayed the same, for example, but there were other pieces that had to change.
So I'll maybe throw some things out there that like I've heard from this group. And the one that comes up sort of initially is the repartitioning. You need to sort of evict all the workloads from all of the partitions before you can change how the cores for a GPU are arranged, and that what sounds flexible on the surface, when you actually start running things, particularly in a batch context, there's always something running on those GPUs. You never get a chance to actually repartition anything. So that's one thing that I've heard. I think there's another thing that I heard from the Armada team, which was around sort of understanding the current state of from DRA was like we were going to have, because the schedulers will sit above all of these resources and need to know what's happening with the resources to be able to make scheduling decisions. So we were going to have to like poll the DRA API over and over and over again to get a current state of things, and that wasn't terribly appealing. So like just some things that I've heard to kick things off.
Do you want me to go? I can discuss some of those things, or are people already familiar with the overview? Or do you want me to do the
maybe start there. Just a brief bit of context, just to make sure everyone's up to speed. Yeah.
Yeah. If you can give me permissions to share. Maybe I already have permissions to share. It looks like
I think so. Yeah.
Okay. Okay. So here's the. This is the presentation from last NA that Patrick and Kevin did. Yeah, I mentioned, the whole goal, right, is this trying to teach Kubernetes a deeper understanding of accelerators and other specialized devices, something deeper than device plugin. So, like, to give the really brief description, it's four things. Going back a step, the way before DRA and the way that it's still a GA way to do it, that devices are handled in Kubernetes is through extended resources. So nodes advertise that they have some sort of customized thing, and it's a string and a number. That's what they advertise. And then on the pod in the container spec, you could say, I need, this string and this number. And typically, the way people would, like, if they had a node that has a certain type of GPU in it, they would advertise nvidia.com/GPU, and then they would put a label selector on the node. And so you'd use a label selector and that extended resource. And that works fine a lot of the time. But if we want to handle some more advanced use cases, then we need more information. So the first thing that is part of DRA is a way to publish additional information about the devices, a way to model the hardware inside of Kubernetes in a way that the scheduler and other components that are running on top of Kubernetes can have a deeper understanding of the device. Now, it is primarily focused on scheduling. So what that is, it's called the resource slice. And the resource slice allows the vendor to publish the specific devices that are running on the node. And instead of just a count, it's going to say, no, I have these devices, and it can publish a bunch of metadata about those devices, including things like how much capacity, different types of capacity, memory, cores. I think in the NVIDIA case, they publish 7 or 8 different capacity values that could be used, you'll see later in our scheduling requests. And then the other piece, that's the second big piece of it, is the resource claim API. So this is the equivalent of the extended resource, but again, it's a richer API that allows requests to be made in different ways. So rather than just being able to say, I want 5 of this string, you can say, I want, this type of device, and I want any of this device class. We have a concept of a category of devices. I want anything in this device class that has at least 30 gigs of memory and 3000 FP64 cores, is the example here. And so it's basically enables the scheduler to have some optionality in how it satisfies the request. The goal being, hey, can we get people to stop specifying things exactly? We can allow them to specify them exactly because the API supports that. But if they don't need that level of exactness, then can they specify what their actual requirements are, as opposed to specifying some specific instance of those requirements. Third part then is the scheduler code to match those two things. And the fourth part is the node side things, how we actually actuate those scheduler decisions. So that's kind of the very high level. It's really just it's the same way the scheduler has always worked, except that now we have a richer API to describe devices and a richer API to describe requests for those devices. We allow some things. Well, we went GA in 134, but we allow. Let me see if we have some examples in this deck. I might need to switch to a different deck. Yeah. Let me show. And feel free to stop me and ask questions too, or if you already know this, we can I have another deck where I could show some of the examples. So in that request, it's not just requesting an individual device, right? It's requesting many. You can request many devices from across different vendors, and what that lets you do is. Sorry, I'm trying to find the right tab here to share. Here it is. No, that's not. There we go. What that allows you to do is things like, oh, okay, I want to get a NIC and a GPU, and I want them to be on the same PCIe route, even though the NIC is managed by, some Intel driver and the GPU is managed by some NVIDIA driver. We have a way of standardizing certain metadata about those devices, and then we have a way of matching across the individual types of devices. So that's kind of the generalization of what we had before. So some of the things like you could do, this is an example of a resource slice being advertised. You can see there's additional metadata about it, including capacity. And then when you go to actually request a device, you start with a device class. This is sort of like a shorthand, and it's created by the administrator. So the administrator can say, okay, I'm going to make a device class for all GPUs, NVIDIA GPUs, or I'm going to make a device class for a particular model of NVIDIA GPU, or they can even attach configuration, right? Like this is a GPU configured for time slicing with this particular parameters, right? So then that can be requested when the user makes a request in a resource claim. They just put device class, and it automatically gets whatever's in the device class. In addition, the user can layer on top additional selection criteria and constraints and configuration even. So in this case, you can see that, and I can make this bigger, I guess. In this case, the user starts by asking for any NVIDIA GPU by using the device class, but then they layer on an additional selection criteria to say it's got to have at least 80 gigs of memory. You can also then, like I said, use that to configure a device. So here's one that configures for MPS sharing. So when this resource claim is allocated, it will end up with reconfiguring the GPU for that. So it also allows sharing. I'm not going to go into all this because maybe I'll try to get to your questions more, but you can also use it to share GPU. So by a resource claim will allocate a GPU, and then you can share that resource claim among different containers or pods. And depending on those configuration parameters, the sharing will work in different ways. Finally, multiple devices with constraints. So this request is saying, give me a GPU with at least 80 gigs. Give me an RDMA virtual function. Make sure that those two are on the same PCIe route. So that way you get GPU direct and you get better performance. We are building out a whole bunch of stuff. This is from a year ago. So many of these things have been implemented. If you're interested and we have time, I can show you the latest version of this for where we are today. So that's the super short, high-level overview. Now,
can you go back to the slide 8 real quick there? There was something I just wanted to see.
Slide in the last deck?
In the last deck, yeah. I think it was slide 8. I was just trying to see if it linked up with slide 9 somewhere. Okay, device. Okay, there's the device class name.
Not showing you this. So I don't know which one are you looking for?
Yeah, I think it was just before this one. The one before this. Yeah, there. Okay, so driver is GPU NVIDIA.co. I wanted to just see the driver was the same thing as what's on the next slide.
Oh yeah, well, if it's not, it's an error in the slides, not in the.
No. I was just like wanting to see that they were linked up somehow.
Yeah. So yes, the way they link up. So the resource slice says its driver in this case, it says what's node it's on. You actually can, there's a few options around the node and the pool, or how the devices don't have to be attached to a specific node, like most of them are. That's our sort of canonical use case, is node local devices. But in fact, you could advertise multi-node, like things that are accessible, like say a network volume you could advertise that's say accessible to all nodes in the network, in the cluster, or to some subset of nodes with a node selector. But you can also use that to model like multi-node devices. So like at Google, we have what we call TPU slices, which is like a block of machines that where the chip-to-chip interconnect fabric is programmed in a certain way, and we can treat that as a single logical device, and then we can allocate that. And eventually, with work that's going on upstream right now, we'll be able to life cycle that along with your workload. So like gang scheduling, I know, is of interest to this group, right? So what Kubernetes calls gang scheduling, and so if upstream we're working on something called a pod group, and so the idea is that with a pod group, that might be all or nothing scheduling, and additionally, that might be corresponding to, say, a replica and a leader worker set. That replica might need a TPU slice of a certain size. And so with all the work going on upstream in 136, this will be alpha, hopefully. We make the cutoff. You'd be able to life cycle that TPU slice with those leader worker set replicas. So each time you scale a leader worker set, you get a new replica. We automatically allocate a new TPU slice within the fabric. And then when you scale down that leader worker set, you delete the replica, we automatically release that TPU slice. Eventually, compute domain may work the same way. It doesn't today. It works a little differently today. But NVIDIA compute domain conceptually is a similar thing, but it predates some of this functionality. So it has a different way of working today.
Cool. Jonathan, Jonathan, you want to introduce yourself, just so John has an idea of where people are coming from?
Sure.
Nice to see you, by the way,
I'm
Jonathan.
Yeah, nice to see you. I'm at Lawrence Berkeley National Lab. I work with NERSC, and so we have some interest in particular in DRA, and using this for sort of the workflow environment nodes and login node resources that we have in future systems. So I'm curious in the definition of the resource slice that you set up, if it can be done in such a way that it's MIG aware, so that you can kind of subdivide the GPU slice into. I missed the beginning of your talk, so perhaps you talked about it.
I didn't talk about MIG yet, but that's exactly right. So the idea is that the resource slice is a modeling API. In fact, we have a CPU driver. Marlo's been closely involved with that. But the NVIDIA just released they just GA'd, it's been out for a while, but they just GA'd their GPU driver. Compute domain's been GA'd for a while, but the GPU driver just GA'd. In that GA version, MIG is an alpha feature, but you could enable it. And the way that MIG will work actually is pretty cool, because this kind of gets back to what Alex was saying earlier. The resource slice can contain all the possible configuration, all the possible actually contains all the possible configurations of the GPU, not enumerated. But what we do is we say, okay, here's this GPU, and it has a certain set of resources that are shared amongst the individual MIG partitions. We call those counter sets. And then each type of MIG partition, when you allocate it, it will consume some of that. And so this allows the scheduler to actually calculate put it this way, the slice will contain all the possible partitions that can be created, and enough metadata that the scheduler can figure out that if you allocate this partition, these other 6 partitions are no longer available. and they fall out of the scheduling possibility. So this allows like us to schedule or auto scale without kind of waiting for actuation. Like we can iterate and we can simulate multiple allocations in a row and make sure that all of those can be satisfied. And then on the actuation side, let's say you come in the scheduler, you put in your resource claim that you want a particular partition size. It will look through the available GPUs that could be partitioned, and it will pick one, and then it will dynamically reconfigure that GPU to have that partition. And I don't think there's the limitation Alex was talking about earlier where you have to evict everything, because now like it's kind of has awareness. I'm not familiar with that limitation. Maybe that's a GPU operator limitation. Like GKE does it differently. We statically partition when we do MIGs. So like it's not something that comes across. But that, as far as I understand it, from NVIDIA, that shouldn't be an issue with their new one. Like you should be able to actively repartition without disrupting workloads. So MIG is once we get the resource slice feature that's needed for that is in alpha in 135, will be beta in 136, and the GPU driver feature that populates that API and actuates this reconfiguration is alpha right now, and I'm hoping that they will make it. I don't know if they have a beta concept or they just go from alpha to GA in their driver, but their next release, which should follow shortly after 130, Kubernetes 136, should be able to do that. So anyway, the short answer to your question is yes. MIG will be fully supported in what we call dynamic MIG, where you could even say stuff like, give me any GPU with at least 8 gigs of memory, and then it will pick the smallest partition that it can create to satisfy that request.
Okay. Is there some then impact if instead of having static partitioning of your MIG that you throughout the course of workloads being submitted, that you re-partition your MIG itself? You change the sizing of the MIG sort of dynamically throughout the course of workloads that are being submitted. I mean, you run into scheduling issues with trying to like pack things and potentially orphaning things if you kind of are changing things dynamically. But is there support for that? And
so that would be like, I don't think anybody's implemented that yet, like a defragger or something. It's possible, but it's not part of the scheduler. So all of this is constrained by the Kubernetes pod to node scheduling, right? Everything's just still, we look at one pod at a time and we schedule it. So there is a lot of effort going into workload aware scheduling, which has a little bit bigger view. Like I was talking about earlier, you could look at this set of pods all go together, and so there's topology. They could be in the same topology, things like that. But that's kind of an orthogonal effort. I mean, they integrate, but it's not the same effort. Fragmentation isn't something that upstream we're directly addressing. It would be something that would have to come in later and say, hey, I see this as fragmented, but the data should be there to do that.
Okay. It's interesting that just jump in and say that the workloads API is the next conversation we're having with Kevin after KubeCon. It'll be in April, whenever the April next meeting is.
Which Kevin? Kevin Hannon or?
Kevin Hannon, yeah.
Okay.
Sorry, we're casual around here.
There's just too many Kevins and there's too many too many Tims. There's so many Tims I can't keep track of them.
Matts and yeah, it's surprising here. The only overlap we've got is you and me, Alex. Yeah, too many Alexes sometimes.
So you had a question, Alex, about like how we track. It sounded like it was about how you track available resources.
Yeah,
so
yeah, exactly. Yeah.
Resource slice is a declaration of capacity. It does not change when allocations are made. Allocations are are the way it works upstream is the kube scheduler keeps an internal cache of all resource claim allocations. So when an allocation happens, it gets written to the resource claim status, and the scheduler rebuilds that cache whenever it restarts. So and it just does watches. So if you have an external scheduler, it's going to have to watch resource claims and accumulate the allocations that it or others make, and apply that on top of the resource slices. We do have in 136, we're working on a feature for users to be able to go in and say, hey, can you show me the capacity of this resource pool? And it'll go through and it'll do the calculation for you. The thing is, it's kind of an administrator level thing because resource claims are namespaced. So like if I'm a namespace confined user, I can't really see that, right?
Yeah. I think the only change that I think we'd sort of be interested in, because that's still us polling something on some regular interval to see what the resource claims are.
Well, I mean, you'd use watch. I mean, if you have support for watch, like that's how we normally do it in Kubernetes.
Yeah, so like our schedulers will need to do that or something. Like there's nothing that's sort of emitting changes like deltas between the previous resource claims state and then the like what was released and what wasn't. I think that's what my team was saying could be more useful than us doing a watch or polling. I mean, because it's not, yeah, watch is like you're on the terminal, you're running watch.
No, I mean watch. So the Kubernetes API server supports watch,
yeah,
which lets you
watch, right?
Well, kubectl watch is the CLI level version of it, but in the actual API, it's a like a notification based, like you're subscribing to a stream, and
okay. Maybe that is the
events.
The right mechanism.
Yeah.
That I wasn't.
That's how it all works internally. Like so, the scheduler. I mean, the scheduler is making the writes itself, so it already knows about them. But like for everything else, like this thing that the kube controller manager is watching these things, and it keeps an internal cache of the entire state, basically, of all the things it's interested in. And any change that's made, because it's based on etcd, any change that's made to etcd automatically propagates out to whoever's subscribed.
Okay, sorry, I stand corrected. Yeah, that is fine then. Just looked it up, and that is what I think we wanted.
Okay, cool. Yeah, I mean it's it's memory intensive, right? You're holding a bunch of stuff in memory, but I don't think there's any really easy way to do it. One thing we talked about, but have yet to implement, which I think would be useful for potentially third-party schedulers, is a way to atomically write the allocations, right? So that you could, like right now, you don't write it to the resource slice. Every resource claim just makes it, and the atomicity is enforced inside memory in the scheduler. So that makes it really hard for a secondary scheduler, another scheduler, to come in and like allocate something, because there could be a race condition where it gets allocated by the kube scheduler at the same time. Mm-hmm. Unfortunately, it's a huge challenge, more so than it ever should be, just because of the way the Kube API server works and etcd works, and we don't. It doesn't have all the transactional semantics of like an RDBMS or something, and so you can't easily do, at least in the way Kubernetes uses etcd, you can't easily do cross resource transactions and things like that. So it's kind of like we've talked about it, but it's a really heavy lift to get to that state.
It's funny, everything comes back to etcd at some point. I mean, we created Armada specifically to get away from etcd. So like, yeah. Alan, I was curious whether any of this, like, yeah, I don't know whether you're scheduling at this level, or whether you're focused on more of the higher level orchestration, or like, yeah, I'm just curious.
Yeah, no, we absolutely are. And it is an area we're kind of actively looking at, actually, how we do kind of more, we would call it sort of attribute-based scheduling, but effectively understanding the attribute requirements of the tasks and the resources they run on, right? Same problem space. It was interesting hearing about you kind of looking at sort of a parameter explosion almost of the slice, and then subtracting kind of what would no longer be available. I was trying to think through how that would work in our environment, because I think we probably deal with more parameters than would be viable. It would be quite a large sort of multi-dimensional. We're looking at all kinds of things like RAM, CPU architectures, GPU models, RAM, and I think it gets to be quite a big thing. Currently, what we do is really, we have kind of a matching algorithm between, and we allow people to kind of free form, kind of use tagging mechanisms to say that the attributes they actually care about, so we don't have to kind of track everything. But yeah, no, it's a very active space for us as well.
So which project are you working on?
I look after a commercial product called Yellow Dog. So we have a workload management tool that's basically a scheduler and compute provisioner, kind of, which operate hand in hand. So based on kind of what you're asking for, we'll go and provision that dynamically. What we tend to do is kind of create what we call kind of workers on a node that we provision, which controls the concurrency, the parallelism on that system. But we're moving to more of a resource-based workerless model, where based on what you ask from a task, we will take that resource away from the available system, and the residual would be available for future tasks. So I think that's kind of the direction we're sort of heading with that.
Right.
That sounds very similar.
Is that on top of Kubernetes, or that's your own management platform?
Sorry?
Is that on top of Kubernetes, or is that your own management platform?
It's entirely our own. We deploy it and run it on Kubernetes, but it's entirely kind of it's a control plane of its own for HPC workloads.
Got it. Okay.
Because you also, just for context, like, you'll spin up non-Kubernetes workloads through your
Actually, yeah, that's primarily what we do. We do have some sort of nascent examples of running workloads on Kubernetes, as well as just our management tier. But primarily we deal with an instance as a unit of compute, wherever that comes from, whether it's a bare metal or what we call configured compute within an existing data center.
I see. So you run your control plane on Kubernetes, but you're directly managing the hardware.
Exactly. Yeah.
That's the data plane.
Yeah.
Okay. So I mean, Marlo and I have worked. So one of the goals in DRA was to give external schedulers enough. So we have this problem of, right, we can't necessarily just let external schedulers take over because of the atomicity problems and race conditions and stuff. But what we can do is allow external schedulers to program the requests very specifically. So while it's possible to say something like, I'll take any GPU with greater than 8 gigs of RAM, it's also possible to say, I want GPU 7. And so the idea is, like, we're also building a CPU and other native resource drivers. So something like Slurm can come in and say, I already decided which CPU, which GPU, which NIC go with this container, and I'm just going to tell you this is exactly what I want, and give you no optionality, give you no choice into what to do, and be done with it. So the idea is to kind of cover both of those, categories.
That's actually very interesting for us in Armada. Like, over time, Armada has become more autocratic in its scheduling decisions and wants to do exactly that, to sort of cut out as much of the Kubernetes loop as possible. Just like, go directly to this thing because I know best, kind of.
Right, exactly. And you can do that. It requires, I don't know how you do it in Slinky, Marlo, if it's like a webhook where it requires probably rewriting resource claim spec from what the user put in, like to like, oh, we've made all these decisions, and so we're going to rewrite that and encode those decisions. For multi-node, like you can also just write the allocations directly. You might need to, so the resource claim has an allocations in its status. You could with a schedule, you could have a scheduling gate, and then you could make the allocation decisions, write the allocations, and then the kube scheduler will ignore that resource claim. So that's another way you could have a raise condition there because of what I talked about earlier, where you write that allocation, but before the scheduler sees it, since you're writing it, the scheduler's watching those resource claims. There's a small gap there where it hasn't yet received that update. If it's scheduling some other workload, it might grab those same resources. So if you gate everything, then that's not a problem. But if you there are some risks, right, with doing it that way. Whereas reprogramming the spec side of things and changing like the user intent, right? The spec is the user intent, and sort of like injecting your own logic, your own decisions there. Then Kube Scheduler still does the allocation, and you don't have that raise condition. So those are kind of two different options.
Yeah, I think we, as I say, try to avoid Kube Scheduler if possible.
Right.
I'm curious, Alex, does this affect any choices that your team is making? Because you're often focused on sort of more traditional HPC, FSI stuff, right? Yeah.
Yeah, I'm not so much GPU as well. So, a lot of our customers are still wrestling with the wonders of AMD. So we're some way off GPUs being a particular problem, but I'm interested in this space, and we are working with customers around. I'll have my colleague join the call in future times to talk about Orb, the open resource broker that we've engineered, which does have in development in cooperation with Morgan Stanley a Kubernetes plugin. So I'm curious about how far down the line they've gone with things like MIG and support for other device types. So I think that's probably a conversation for a future session, is to dig into like what does that mean for the open resource broker from our side.
Yeah, cool.
The other thing that just came to mind as well, actually, hearing Alan speak, was the concept of requirements versus preferences, and to what extent you're able to express not only that I require this kind of size, shape, GPU, and configuration, but being able to express that I would prefer that, but if it's not available, I'll take something else.
So that's a feature we do have in the resource claim. We call it prioritized alternatives or something. Basically, you can say, like the canonical example is, hey, I want an H100, but if you can't give me an H100, give me two L4s or whatever it is, right?
I see.
And so, but you can have, I think, like up to like 8 alternatives, right? And so we'll have examples where it's like, they're kind of more demonstration. I don't know if people would use it in production, but you have things like, okay, I'll take TPUs. If you can't give me TPUs, give me GPUs. If you can't give me GPUs, give me 40 CPUs, right? And so there's some warts in that journey, but for the most part, we can kind of do that. So
any thoughts on how that scales? Because if you have too many dimensions and too many layers of preference, like at what point does actually scheduling become very expensive?
That's a risk for sure. They're evaluated in order, and so it's means that if you've got 3 options, then it's potentially up to the equivalent of scheduling 3 separate pods, right? Typically, it's more like people use 2, right? It's like this or this.
It's funny. Like in my mind, I'd always imagined something a bit more ornate for that kind of thing, where there's some matrix of fallbacks and preferences. Like if this then falls back to this. But actually, as you say it, in practical terms, most of our researchers are like, give me this bestest GPU that we have. All right, if that's not available, then the second best one, but I need one or the other. Workloads aren't so flexible generally that they can just run anywhere they want. And so, actually having 8 preferences is probably plenty in that
More than enough.
regard. So
I wonder if that's going to change though, because like the corollary in my mind is, you look at CPUs today. So we'll have customers who have their number one CPU, their number two, and they have or EC2 instance, right? They'll rank those. There'll be 200 of them. Is there a world in which GPUs in 10 years' time, there's so many generations of different size shapes that you have more optionality, and cost, price, performance becomes a factor, and so customers will want that kind of ability to have a much wider spread of preferences.
Probably need a different API for that.
Okay, well,
And
I'm not
define
generating
best,
work for you,
right?
John, but I'm just curious.
I think the solution there is AWS not to have so many instance types, surely.
I'll take that back. Yeah.
Yeah. Thank you. Appreciate it.
You made another comment about this. What did you call it? The broker thing. So just to be clear, like all of this DRA stuff is like the way I think of it, and I don't know if it's fully there, but the way I think of it is as a resource modeling API, and so that could be like we can model the same resources that are sort of standard resources in a node in Kubernetes, right? Like we could easily model all that stuff. Plus we can model more, right? Like the MIG stuff, more sophisticated. We also have a feature where we allow partial consumption based on resources, just like pods partially consume nodes. We can have resource claims that partially consume devices, and then those can be then used by pods. So like we'd actually you could completely replace, most likely you could completely replace the traditional bits of scheduling, like with just devices. So I'm sure there would be gaps, but for the most part, it's there. What that means is that people can get really creative about what kinds of resources they model in this API. It doesn't just have to be GPUs, NICs, and CPUs and memory. Like it can get pretty creative. So I'd be curious to see what you were saying, like how far have people gone with this other open resource broker thing. Like I'd be curious to see what the use cases are there and whether they're things that whether there's some relevant integration or something.
Yeah. Okay. Well, there's session for next time.
Yeah, I guess so.
So we're coming up towards the end. Any last burner questions from Victor, Philip? I think Tommy had to drop.
Yeah, actually, just like Alex bring up in the beginning, OCP is doing something a different layer, kind of a fully automated optimization on the hardware only. I think there will be interesting discussion when John present this to the OCP group.
Yeah, and do you want to just give a plug for when that group meets? We can put that in Slack and stuff. But it meets.
Yeah, I'll be there April 17th, I believe. It's right now because of KubeCon and everything. There's travel and it's going to be hard.
Yeah. Cool. I'll try and join that. It was a good meeting, the OCP one. We'll try to put things in the Slack so that people can join that one too if they're interested. It's more hardware focused, as Victor said. Philip, you said you looked like you were about to ask a question.
Thank you. Yes, a quick one. So I understood that you simulate multiple allocations, taking into account all of these conditions that we might put in the resource claim. So does that happen on a trigger when resource slice is deleted, added, also with the resource claim? So how does it scale? When does it happen?
Great question. So they're actually completely distinct. So think of it as like the resource slice can change. It doesn't modify existing allocations. They stay there. We do have a concept of device taints where you could put a taint on an existing device and that would evict any pods using that device. But if you literally delete the device from the resource slice, we're not going to disrupt your workload. So they're disjoint, and there are pros and cons to that, but that's the approach we took.
Thank you.
Well, that brings us nicely to the hour. That's lovely. Thank you so much, John. This was really informative, really good session. I'm glad that we've got all this recorded because I think a whole bunch of people in the Slack channel will be very interested in the discussion. I think just because of the run up to GTC and KubeCon, there were fewer people than normal here. But thank you everyone for joining. Really good discussion, and have fun KubeCon if you're going there. Have fun at GTC if you're going there. We'll see you back in like a month and talk about the Workloads API with Kevin Hannon and you know, how all these things intersect. So yeah, cool.
Awesome.
Thank you very much.
Thank you. See you guys.
Yeah.
Thanks, folks.
See you. Bye.